All right, we're a couple minutes past, so I'm going to go ahead and kick off the meeting. Welcome to the CNAB public meeting. Today is February 13th. The agenda link should be posted there in Slack. We keep that up to date on a HackMD document. Jeremy is keeping track of the notes for us today. So the rough agenda for the day is we're going to kick off with a demo of Porter, which is a build tool for CNAB. There's a section for quickly going through what's changed in the specs since over the last couple of weeks, since we've been very active and we've been assuring people that we're trying to close in on something that's going to be stable for a longer term. We are going, Chris and Gareth are going to give a quick update on the direction they're going with the registry based on the registry meetings that have been ongoing for the last few months. And then, what's the last one? If we have time, we can do a short update on the tough In-Toto stuff where we can just kick that off to next week. And then, of course, if there are any other things that people would like to discuss, feel free to drop that in Slack, and Jeremy, as keeper of the notes, will be able to dynamically and in real time insert those into our agenda. So, but first, we'll let Jeremy and Carolyn kick off with a Porter demo.
All right, let me share my screen, and then we will run through a quick demo. Okay, let me know when it comes through. Is it looking okay?
Yep.
Cool. All right, I'm gonna switch to Visual Studio Code just to run through this stuff. So Porter is, at a very basic level, a tool that we've been working on to address the authoring experience of CNABs. It's not trying to be specifically a run tool. It's just really trying to provide a really opinionated experience for making CNAB bundles, with the end result of those things being executable by really any CNAB tool, because it's going to follow the spec. So at a very high level, we've written it's really a tool that has a couple pieces. I'll run just the Porter command line really quickly so you can see what commands we have. So we have a build command, a create command, which I'll show in a second, a run command, which is going to provide some runtime experience, and we'll walk through that in just a second. And then just some basic things like list and version. So if I start with a blank directory, let's make a directory called demo. Type. Okay. So now I've got a new directory. It's empty. It's called demo. There's nothing in it. So I'll run Porter create really quickly. And what that's going to do is give me some scaffolding for what a new bundle might look like. And that entails a CNAB directory. And inside of that directory, there's just a basic run script, which is what will be the entry point for our invocation image. And then a porter.yaml, which is what really is the meat of how you build things with Porter. If we look at that really quickly, bring that over here so it's a little easier to read. Porter.yaml. So in essence, what we have is right now it's a YAML file. We're going to work on expanding that to allow you to use other formats. But right now, it's because we're kind of in the proof of concept stage still, this is just what we've settled on. If we walk through this file really quickly, there's a couple of sections. The top is Mixins. So we've kind of settled on this concept of Mixins as ways to provide reusable functionality for people that are building bundles. In this case, we're going to use the exec mixin. Then we have some metadata that describes what the bundle should look like. We're specifying what the invocation image should look like, some descriptions, the name of the bundle. And then we get into the actual, like the verbs of what the bundle should look like. So when we do an install of the bundle that's generated from this, you can see the steps that are going to be executed. In this case, we have one. It's going to run echo hello world. So if I do a Porter build in this directory, again, if we look, we only have the porter.yaml in the CNAB. So I do a Porter build here. So actually, I need to change this so that it pushes to my registry first. Okay, I'll do a Porter build. And it's going to do a couple of things. It's going to generate the Docker file for me, so I don't have to know how to do that. It's going to build the Docker file for me. It's going to push the Docker file, and then it's going to generate the bundle.json that's associated with this bundle. So that'll take a little bit of time because it's pushing it to the registry. Again, so here's the Docker file. It's pretty lightweight, and it doesn't really bring any build time dependencies because the exec mixin doesn't have those. The bundle.json is pretty simple right now. We didn't define any parameters or credentials, so those are empty. Here's the information for the invocation image. So now I can run that with Duffel, because Porter right now doesn't have any context for how to run bundles. It's really just centered on doing the build. So we can do a Duffel install. We'll call it hey demo.
That might be an empty list.
Yeah, so when that runs, it says hello world. And we can see from the porter.yaml that we wanted to run basically echo hello world. And that's what happened. So that's a pretty simple version of what a Porter bundle looks like. A more complicated one we can take a look at in this Porter MySQL WordPress directory. So let me just kill these files. If we look at that one, the porter.yaml is a little more complicated. In this case, if we go to the top, we have two mixins. Instead of using the exact mixin, we're going to use an Azure mixin and a Helm mixin. And the whole purpose of this bundle is to install WordPress onto Kubernetes, but also to create an Azure MySQL instance. So in this case, we do have to define some credentials because we need to specify how to connect to Azure, and we also need to specify how to connect to Kubernetes. We want to expose a couple of parameters like the user, the password, and the database name. And then just like we did with the exec mixin, we're going to specify what the steps look like. So here we're going to use the Azure mixin to create a MySQL instance, and we're going to use the Helm mixin to install the stable WordPress chart. So when this bundle runs, it's going to run first that create Azure MySQL step, and it's going to create that hello, or it's going to do the Helm install. And one, let me just remove the Docker file and the bundle.json so we can see what they get generated as. We'll do a Porter build here. And you can see there's more stuff that's getting written to the Docker file. In this case, we're going to actually install Helm into the Docker file, and we're going to install the Azure mixin itself because the Azure mixin is what knows how to talk to Azure. And then the same things happen. We do a build of the invocation image, we push it so that we can get the digest, and then we build the bundle.json from that. And that's going to look something like this. So here's the Docker file while it's running. We're going to do an apt-get update inside of the image. We're going to install Helm. We're going to copy in the same things we did before, like the Porter YAML and the runtime. So that's pretty simple. You know, all of this really is going to generate something that lives within the compliance of the CNAB spec. But the CNAB spec is open enough that it allowed us to do this. We also were able to start looking at what dependencies look like. So I can take a look at this porter.yaml really quickly. And here we have another section that we didn't see in the other bundles. In this case, we're declaring a dependency on a bundle named MySQL. And the MySQL bundle is just another Porter bundle that looks like this. So this one's going to use the, oops, sorry, come on mouse. It's going to use the MySQL, or sorry, the Helm mixin to basically install a MySQL instance on a Kubernetes cluster. So this thing becomes a manifest that we can then reuse, which we're going to do in this bundle right here. So when this happens and we do the build of this bundle itself, what actually happens is it takes all of the dependencies. So in this case, all the stuff that makes up that Helm mixin, or that MySQL bundle, which is the Helm mixin, and the whole Porter YAML that goes along with that, and it puts that into the invocation image first, and then it'll run that, and then it will run everything else. So in this case, this is a pretty simple. It doesn't actually install WordPress, but it's going to run the stuff for that MySQL dependency first, and then it will jump in and run the rest of the things for the bundles. So, you know, this could be just another Helm mixin call here to install Helm and pass the stuff in. One thing that I didn't walk through when I walked through this one is that we have this concept of wiring between steps. So if we go back to the Azure step really quickly, when this Azure MySQL instance is created, one of the outputs of that whole step inside of ARM is that you get back a fully qualified domain name. We're going to expose that for the rest of the bundle by declaring an output right here. So we say, after this step is done, we want to make the MySQL_host available for the rest of the bundles. And then we can declaratively say down here that we want to wire that into the Helm install. So we do the same thing with parameters. We do the same thing with bundle dependencies. So you can have parameters or outputs from bundle dependencies. You can do the same thing for credentials. But this is allowing us to explicitly and declaratively say how those parameters, credentials, outputs are going to be used. So we wanted to make, really at the end of the day, we wanted to make Porter a tool that gave people a declarative experience for defining what the bundle looks like, and didn't force them to actually know how to write a bash script or write a Python script that would be the entry point for the invocation image. We wanted to give them a little bit more concise way to do this. Some things we're doing right now, I mean, really, Porter is a work in progress, so feel free to comment, give us suggestions, but know that it is a very actively work in progress sort of thing. But one of the things we're doing is adding schemas to these mixins so that we can do cool things like inside of Visual Studio Code, we can use IntelliSense to say, what parameters does this mixin expect? What outputs does it provide? So that we can, instead of you having to actually write this YAML out, you can use code completion and stuff like that to make it automatically happen for you. Okay, so in a nutshell, that's what Porter is. I'll open it up to any questions right now if anybody has anything. If Carolyn wants to jump in and add any verbs to that, go for it.
Yeah, I just want to add one thing, because the first thing I want to ask is how does Porter work with Duffel? We're in the middle of changing how Porter works with Duffel, so I just wanted to share that real quick. So Duffel is a reference implementation of the CNAB spec, and what we're doing is trying to build on top of Duffel and provide a more streamlined user experience that lets us do not just a pure implementation of the CNAB spec, but maybe a more opinionated, it does an 80% case. And we're building on top of it, so you'll start to see commands from Duffel be available inside of Porter. For example, Porter install will eventually be a command. So instead of having to juggle between the two commands and having to go, right now you have to do a Porter build and then immediately turn around and do a Duffel install. Eventually you'll be able to stay just inside of Porter, and we'll just be calling out to the Duffel libraries under the hood and reusing all of the Duffel code. Yeah, but we're not there yet.
Yeah. But still, at the end of the day, the thing that Porter generates will be able to be run by other tools because it's really following the spec. So that's why it works with Duffel right now. But like Carolyn said, we want to make it a more integrated tool so that it's just easier for people.
And on that as well, we've now got, I think, a bit of a blank repo that Radu set up for basically test data. I've got a bunch of stuff. I think we've a bunch of the people who've been writing clients have got things lying around. We just need to get it all in one place to use. But we can absolutely do some, the main driver for that was so we're all putting test data in one place and we can use it for the independent implementations. There's nothing stopping us doing some crazy cross-tool examples of that working as well.
Yeah, I mean, I think that it reinforces the spec compliance for people if they do the cross-tooling.
Well, ultimately, we'll have bugs in the clients, but if we've got the same bug in multiple clients, it's just easier to catch. For example, I was manually parsing the bits you were showing, and I think there were some CNAB bugs. But I've been writing a client too much. I'll ping you with the things I spotted.
Question, this is Glenn with Normanton from Pivotal. Just about the mixins, do the mixins expose a standard interface that they're all the same, or does it vary by mixin? How do you know how to use a mixin?
Yeah, so go for it. Go for it. I'll take notes.
Oh, okay, yeah. The mixins all support the same standard interface at a base level. At the moment, they all are executables, and they communicate with Porter over standard in, standard out. And they pass just JSON or YAML. They pass YAML back and forth. So Porter goes through and passes just the piece of the Porter manifest that's relevant to that mixin and says, you need to execute this part. And then it executes it and then passes back outputs back to Porter. We may be looking at changing how we handle that, but as long as it meets that contract, it can be implemented in any language, and it can do kind of whatever it needs to do. It can also, the mixin provides information back to Porter using the same mechanism to say what lines in the Docker file it needs. So you saw like Helm was able to communicate back to Porter that it needed extra lines in to install its own binary and things like that. So anyone can implement a Mixin, and we're working on a distribution mechanism so that other people could make an executable for their own Mixins and then be able to install it and use it with Porter and distribute it. But that's kind of like early, and it may change a little bit, but the idea is that anyone should be able to make one and be able to add extra functionality on top, but still have like a common interface.
Yeah, I guess what I was really getting at was I can see it can work technically. I'm just wondering how a user would know how to use a particular Mixin. Are they documented in a standard way, or
each one of the Mixins supports a schema command that says what their Mixin can do. It reports back, like for the install command, what are all the different parameters, what are the enums that they support, and what are all the different values they accept, and it gives you a full JSON schema back. So that drives the IntelliSense, but it also lets users figure out what it is that the Mixin supports. Long term, we may encourage people to use that to build up, say, documentation or a command that you could call and say, right now it dumps JSON, which is helpful for automation, but it may be nice to be able to say, Porter Mixin Helm, give me your schema, and then print out, say, like a human readable format of that as well, so you can kind of discover and see what's there. But otherwise, we're looking to get better integration with different editors to just help guide people through autocomplete.
Okay, thank you. That's good. And just one other comment or question, really. Do you anticipate Porter being able to express dependencies on non-Porter bundles in the future?
No, that's not on our roadmap because the spec itself doesn't have enough information for us to do anything at all with it. Like, it would be missing all that information about outputs that you saw us wiring in. So we could do something really simple, like, for example, execute it, the other bundle, but that would be it. We couldn't get information out of it because there's just not enough common.
Okay, yeah.
You have to evolve, like, say, additional parts of the spec to be able to have any sort of agreement as to how to chain together bundles.
That's fine. Thanks very much. I mean, I don't think it's a requirement. I was just interested. Thank you.
Oh, I guess there were a couple questions in chat, but it looks like, Jeremy, it looks like those are all. Yeah, so I think the question in chat was basically, do other bundle runtimes need to know anything about the Mixins in order to run bundles built with Porter?
Yeah, and the answer to that is no, because we build that into the invocation image itself. So Porter really is two pieces, and there's two phases of each Porter bundle. Carolyn mentioned that the Mixins provide stuff at build time. Porter provides like kind of a complementary runtime piece. So if you look at the run script, really what it's doing is invoking the Porter runtime, and the Porter runtime knows how to parse that YAML file right now to say, I'm going to invoke the exec mixin, I'm going to pass it this stuff. I'm going to invoke the Helm mixin, I'm going to pass it this stuff. So all of that's really contained within the invocation image itself. It doesn't bleed outside. The invocation image and the Porter runtime itself knows how to speak CNAB. So it knows how to turn parameters into the things that get wired in, credentials get turned into the things that get wired in, and how to do the outputs within the bundle itself. There's not really anything that defines in the CNAB spec right now like outputs in general. So like when this bundle is done, you have these things. Something I'm trying to write up right now because I think that's something that might be useful across the board. But right now everything's contained within the invocation image itself, and the interaction with it is really scoped to how CNAB expects to operate with invocation images.
All right, thank you guys very much for doing that demo. So time-wise, the original slot for this meeting had been an hour, and after the first meeting, we were afraid we might not have enough to go for an hour, so we dropped it back down to a half hour. It's 10:20. It's 9:21 Pacific, and we just barely made it through the first item of our agenda. So if people would like to weigh in on the chat channel about maybe expanding this back out to an hour or doing 45 minutes, we'll collect that information at the end of the call and try and make a decision what we want to do going forward. So if you have opinions about that, go ahead and drop those in chat over the course of the rest of this meeting. I'll let Radu start off with giving feedback on that one, since he was the one who asked for it to go back to an hour. Okay, so to try and get through things quickly, what I'm going to do is I'm going to go through the changes I know of in the spec, just kind of in list order, explaining what they are, and then pass it on to Chris to give a quick update on what the plan is for the current implementation of the registry. We won't do discussion on that as we go. And then if we finish all of that stuff and have time for discussion at the end, then people can raise questions and circle back. Otherwise, we'll deal with questions on that in the issue queue in order to meet our commitment and be done by 1/2 today. And then I'll just go ahead and call it now that we'll defer the tough and In-Toto stuff for another week. So quickly, I wanted to update. 2 weeks ago, we said we were going to try and move quickly through resolving issues with the spec. So here's where we are. There's an open pull request for adding license in as one of the metadata things. It was already in the schema, but it hadn't been added to the spec. There's been active discussion on namespacing rules, and the consensus seems to be coming down to following OCI and using reverse domain name-like ones. So we originally it was example.com/foo was our namespacing method, but then with interest from OCI and the way labeling was going, we've switched it back to com.example.foo as the way we were doing things. So the current PR requests are, I think, all updated to reflect that, but we haven't necessarily finalized that naming scheme yet, but it will get finalized in the next week. We have finalized that JSON will be represented as canonical JSON, which means the outer bundle.json can be reliably hashed by multiple different implementations, even if those implementations would otherwise using just JSON serialized to a non-hashable, non-repeatably hashable format. So we use canonical JSON as defined by the One Laptop Per Child project, because there are actually 3 specs named canonical JSON, but that's the one we're using. So that got merged this week. There are 2 open proposals that would be good for people to weigh in on if you have time. One, and I know Ryan and several other people on this call have already weighed in on, is whether we can figure out how to use JSONSchema for the parameters instead of using the original method, which was derived from ARM template format. Ryan had proposed an even more advanced than the version that I had PR'd in there. So if people want to take a look at that and weigh in the issue queue, that would be good. I think it was you, Ryan, right?
Yeah, I haven't actually proposed anything yet, but we had started a conversation about it.
Right, yeah, okay. We had at least gotten to the point where we were discussing if there was any reason not to do it. So we're basically working our way from probably an overly simplified definition of what parameters and credentials could contain to something where we maybe, end result could be structured testing of parameters, but we'll see. And again, I'm interested in that. Ryan's interested in that. I think Radu has shown a lot of interest in that, and almost everybody from the Docker team has shown interest in that. So we can keep iterating on that as we go. Second proposal that would be great if people could weigh in on. The original spec implemented parameters differently than the way we do it now. And part of it was that it auto-generated parameter names as CNAB_P_, and then the name of the parameter, and those were injected as environment variables. In efforts to change things and make the CNAB more flexible, we started allowing people to override the names and specify environment variables or target files. The question was raised earlier this week whether there's any reason to have CNAB_P_* still supported. So I opened an issue for that. Feel free to weigh in on that if you have opinions, because it's great to get rid of legacy before you introduce it formally in the first place. Okay, so I'll hand it over to Chris. We still have about 4 minutes left in this meeting, so I'll give it to you. Oh, one other thing. I would like to introduce Karen Chu, who's on the call today. She is going to act as the community manager for this. You might know her from her keynote at KubeCon last December, or from all the many things she's done with Helm Draft Brigade and other projects. But she's, if I'm not mistaken, you're formally stepping into that role, the role for CNAB, right?
Yeah, I'm going to currently shadow Loggy for a little bit as I ease into the role.
Okay.
Yeah.
All right, go ahead, Chris.
Okay, yeah, so as a lot of you know, we've been trying to finalize how we're going to store CNABs for registries. it's a complicated thing because we want to make sure it's going to work with existing registries without too much modification, and we want to make sure we can store all the stuff we need inside the format itself. The proposal is to go with the OCI index method that is pocked inside CNAB to OCI. The reason for that is that CNAB is inherently references a list of images, starting with the invocation image and then having the other images as well. So using an object that's an OCI object that encapsulates that makes sense. We also think that going forwards, there will probably be something added to the OCI spec that acknowledges that artifacts that are stored in registries are not just a single image. In the same way that the OCI index came from multi-arch and the hacks around that people were doing, using tags basically to push the same image for multiple arches. An OCI index came from that, and I think that the OCI index will evolve to support other artifacts. So we think it's the correct direction. I will try to put up. I put up a PR for the Docker/CNAB to OCI repo, which has the latest example of what we're proposing. I think that's the correct direction. There might be some minor changes that we make to that, but we can maybe open it up for comments quickly. But what do people think?
Chris, I think any implementation that sounds like, so I mean, the original goal of pushing CNABs or pushing any kind of object or artifact to the OCI registry, anything that is OCI compatible, it sounds like a good way to go forward, especially since this is moving at such a rapid pace. So I think let's definitely keep on going on that. Could you mind posting the actual link to the thing on the CNAB to OCI spec?
Yeah, so what I'll do is I'll post the latest PR that I've put up with an example, because the library hasn't been touched in a while, and while we've been iterating on how to do this, there's a lot of context here that is lost if you weren't in some of the meetings. I'm writing up I'm updating the README on the CNAB to OCI thing to encapsulate some of that context. I'll try and push that as soon as possible as well. So I'll share this in the CNAB chat. Sorry, on my machine, I'm not on Zoom right now. And basically, you can see the current example there. It's to summarize, the OCI index doesn't give a mechanism of giving a top-level type, which is a bit of a problem. But I think we should solve that with a well-known annotation. And once we have more of these artifacts stored in registries, we'll have a better path for some formalization at the OCI spec level. We're still proposing storing the config with a custom media type, but at least at the top level, the type will need to be communicated using an annotation.
All right. Awesome. I hate to cut off the discussion, but we're right at time now, and I wanted to make sure we respect people's time. So the consensus seems to be an hour for next time. We can continue to discuss that in the Kubernetes or the Cloud CNCF CNAB channel. But that seems like we'll probably go to that for next week, so we can have a little more time. To wrap up the CNAB and registry story, there was a question, how and when should this be part of the spec? It will be, the request has been made that this be added to the spec after the core spec has been solidified, because people are most anxious to just build CNAB bundles correctly, and we didn't want to burn any time. So we're probably talking about a month out on that one still. But in the meantime, that should buy time for experiments to continue on. Okay, if anybody would like to do a demo next week, please drop a message in the CNAB Slack channel, or let Jeremy know, or let Karen know, and we'll get that on the agenda for next week. I think I can probably speak for everybody saying I really like starting with demos and seeing what people are doing and how things are progressing, because it introduces everybody to different ways of looking at how CNAB can be used and what it's good for and where its strengths and weaknesses are. All right. Thank you all very much. We will see you again next week. Bye.